This is the fifth axis finally on a base plate. You can use these nuts to screw into the T-slots on the 3040. The 100-to-1 harmonic drive on the fourth axis here. This entire cradle is free to spin. And the end stock over this side. So the idea is that the fourth axis moves in this direction here, and what's attached here can freely spin this way. So you've got a circular motion here and a circular motion here, and the X, Y, and Z in the existing CNC to allow the cutter to get into various places. So down here I decided to make the fifth axis tray have a little cylinder of aluminium with a rectangular key coming through this half-inch piece here. I went this way rather than taking off this and attaching it directly to the harmonic drive, because the more you have to play around, the more you have to remove things, the less likely you are to want to put the fifth axis in. So this way I can just slide that in and keep using the same plate here to attach this guy to the T-slot bed. I obviously have to drill out some more holes so I can move this forward, depending when this is not on. I'll just be able to move this in to various locations and still attach it to a different workpiece. And the fifth axis, I'm just currently using some M5 bolts to offset the stepper motor. These are the bearings that I'm using for belt tensioning, which is obviously very flimsy at the moment because I don't have those in use. On the underside, I have, since last video, flipped the bolts around, so that any spare, in this case I'm just using shorter bolts, but these guys are going through the opposite direction, so that any spare part of the bolt there is just sits on the top here where it can happily exist rather than hitting the tray underneath. This assembly at the moment, it's always a trade-off between having it bind if you have it done up too tight, or if you have it too loose, actually being able to have it wobble this way. But there's a inside here, there's a small pocket which contains a deep groove ball bearing, and on the bottom side at the moment I'm using another deep groove, which the outer race is forced up against the aluminium, and there's a larger hole, so the inner race is just basically free on the other side. To get around the issue, these are rubber seal ball bearings, and if you tighten them up with just washers on here, sometimes the washer can bind to the rubber, and the inner race moves and the outer race move, and rubber are moving with one piece. So if you just tighten it up that way, you basically get a binding issue. So at the moment I could easily turn apart on a lathe or make a piece with the CNC to just rest just on the inner race, but at the moment I've sort of cut back the outer part of some washers. So here I have two washers and a spring washer sitting just, brilliant camera work, sitting just on the bolt, M12 bolt. So the M12 bolt has the spring washer, two washers, one of which has been sort of triangulated so that it just hits the inner race of this deep groove ball bearing. This may be replaced with some other type of ball bearing, like a thrust bearing or an axial load bearing. The axial load may be better with the one in the housing though. And there's a couple of washers after the deep groove in that housing. This guy, and instead of countersinking, I've just used the CNC to hog out a rectangular area. Initially made it for the head of the M12 hex, but these bolts are actually slightly smaller. It fit perfectly for the M12 hex head. In the tray below, I work out the best angle to be able to see it. There's these little rectangular cutouts over here and over near the chuck, so that the 1/4-inch alloy, at the moment the chuck's fine, but if you open up the jaws a little bit you will hit the tray. So in this case you can still have it open quite wide without binding. And on this side you have a situation where the nut can freely rotate and not hit the bed. And the entire assembly is designed to be able to go from at least 90 degrees that way, which again, you're starting to get sort of getting the angles just right, get a little bit close to the bed. It should actually not need the cutout, but the cutout's sort of handy there. Potentially I could go beyond 90 degrees, which the stepper motor will just hit at about that point, which will stop me if I'm wanting to do undercuts. But on the flip side, the whole thing moves around, and again just sort of goes beyond 90 degrees, but if I constrain it to 90 or 100, then everything will be fine. I'm still using a bearing at the end of this, which doesn't seem to provide much wobble space, but obviously you can detect very small things with trying to wobble them, but it may not be ideal in the long run. This I didn't cut this out all the way through underneath the motor, but it's come in very handy for getting the belt on there. So if you're looking to do your own, having some cut out there so that you don't have to try and contort the belt as much to get it on, you've got a little tray that you can sort of slide it through to get to the other side. So now I've got all of these in place. These guys here are held on by a countersunk M6 from the other side, and they're flush with the bottom plate, which seemed like a better long-term idea than drilling and tapping M6 in it, because always attaching and detaching the bolts there I think would have worn it down over time. And that's about all it is. Needlessly 60-61 grade aluminium, but a little bit of extra money makes it nice and shiny and more rigid, I suppose.